Okay, so this warm-up is on page 27. Take a minute and see if you can summarize what the different first derivative test, the second derivative test, and how to find an inflection point. These are the three major topics on your tests coming up. Okay, so the first derivative test is when we find f prime of x and set that equal to 0. It gets us the critical values and the maximum and minimum points. The second derivative test is we find the x values when the first derivative is equal to 0. So then we solve that for x. And then we plug the x's into the second derivative. And we find a number. And depending on what that number is, we find maximums and minimums of the original f of x function. Now for inflection points, that's when we find the second derivative and set it equal to 0 and solve for x. And that gets us the inflection points, or where the change in concavity. Okay, so at the bottom here, a point at which the graph, well, let's draw a sketch. Okay, so draw yourself any curve. I'm going to label this point C. So a point at which the graph of a function changes concavity is called a point of inflection. So here's the x value C, and we have this y value f of C is an inflection point on the graph of f of x. So then the second derivative must change signs when x is c. So this would be a second derivative of negative because it's concave down, and over here would be a second derivative that's positive because it's concave up. There are two situations where this can happen. That is when the second derivative, there's an f, that's a double prime, f double prime. When the second derivative at c equals 0, or we usually don't get, but it's also possible when the second derivative at c is undefined. Okay, so if you turn to page 28, these are going to be our two practice problems today. So the first one says, find the inflection points. So if this were the test coming up, I'm thinking to myself, okay, inflection points is when the second derivative equals 0. We have that little hint for you here. So we're going to do the power rule. We're going to make the first derivative 4x cubed plus 6x squared. Do the derivative again. So 3 times 4 is 12. Subtract 1 from the exponent. 2 times 6 is 12. Subtract 1 from the exponent. And now here comes the algebra of solving. So 12x squared and 12x share a greatest common factor of 12x that I can factor out. And then I'm left with x plus 1. Set each factor equal to 0. And solve, we get 0 and -1 as the potential places for an inflection point. So on my number line here, go in order, sorry. So -1 is first, then 0. So this is negative infinity to -1, -1 to 0, 0 to infinity. Then we have to pick a value, something less than -1. I'll pick -10. We're going to substitute that. I like to use the factored form. So 12 times -10 is negative. -10 plus 1, negative. So negative times negative is a positive. Then I'll pick something between -1 and 0, like -1/2. substitute that in. So that's going to be negative times positive, which is negative. And then something more than 0, I like 10. Positive, positive is positive. So that means concave up, concave down, concave up. So because the signs change at these values, I know there's an inflection point at -1 something and at 0 something. And these y values we have to get from the very original f of x function. So I'm going to plug in 0 first. We get 0 plus 0 minus 1. Then I'm going to plug in -1. So -1 to the 4th plus 2. So use your calculator, substitute in -1, and you should get -2 as a y value. So now for the concavity, I get my intervals here from my chart. So we're concave up from -infinity to -1, and again from 0 to infinity, and then down from -1 to 0. Okay, problem 2, and I'm going to skip the graph. I'm not going to ask you to graph on the test. You can look at it in your calculator if you want to help you see if these are really the inflection points, but you don't have to draw a graph. Okay, classify the critical points using the second derivative test. So this is telling me maxes and minimums, not inflection points. Okay, here's a choice I have to make. I can either do product rule for my derivative, or I think I'm going to multiply this out, and then I'll just do the standard power rule. So let's do that. I'm going to do x minus 3 times x minus 3, because that's the squared. I'm going to multiply those binomials together first. So that's x times x, x times -3, -3 times x, -3 times 3. This is -6x. I'll distribute the x coefficient. Okay, so here's our original f of x. So the first derivative is 3x squared minus 12x plus 9. And I think that's faster than product rule. So now we're going to set the first derivative equal to 0. 3, 12, and 9 have a greatest common factor of 3. So that means I can factor this trinomial easier. So what multiplies to 3 that adds to -4 is -1 and -3. We're going to set each factor equal to 0. Well, that makes no sense. So I get 1, and then 3. And I'm leaving a y value because it says points, so I want to put a y value for those points. If it just said critical values, I could just write the x values if I wanted. So we'll come back and fill those in a minute. Let's find out if they're maxes or no, let's take it back. Let's fill them in. Okay, if I take the 1 and I plug it in, I'm going to go to standard form. You can use your calculator. We're going to get a y value of 5. I take my 3 and I plug it in. 3 to the 3rd minus 6 times 3 squared. You should get a y value of 1. Okay, so now let's do the second derivative. Going back up to my first derivative, that's 6x minus 12. So we're going to take our 1 and our 3 and plug them into the second derivative to know if we have a maximum or minimum. So at 1, 6 times 1 minus 12, that's negative. So that means at 1, if I picture the graph, here's 1, my curve is concave down, meaning there's a maximum at x equals 1. So then at 3, when I substitute that in, we get 18 minus 12, that's positive. So over here at 3, that means my graph is concave up. These would connect somewhere. So since this part is concave up, it's a minimum at x equals 3. And I actually have those y values here, so that makes sense. 1, 5 is higher than 3, 1. There's that point there. Okay, so your homework on your calendar is page 29 to 30. To get both of those pages done, all the answers are at the bottom of page 30, so you can check yourself.